Hello, this video will be reviewing Regent questions from Unit 1, Linear Functions. As I go into each different section, that is a different standard that the Regent could test you on related to Unit 1. So the first section is average rate of change, and you're given a table of values. So you're given outputs, you're given inputs, and it looks like we're trying to find which average rate of change is greatest. Unfortunately, for a question like this, you're going to have to find the average rate of change for each of these intervals. So it'll be a lot of repetition. But first, the average rate of change formula. We know delta f over delta x equals f of b minus f of a over b minus a for some interval ab, right? If that looks confusing to you, you just have to think it's a difference in output over a difference in input. A lot of you remember it as the slope formula. Slope is the same exact formula. M equals y2 minus y1 over x2 minus x1. Look at that, difference in outputs over difference in inputs. So whatever formula you're comfortable with remembering, that's the one you could use. And if you can't memorize it, just remember that it's a difference in output over a difference in input. So, again, we're going to have to find the average rate of change for each of these. So let me separate this into sections. So first, for 1, it's month 10 to 60. So 10 to 60. You're going to do a difference in output. Your outputs are your B's over difference in input. And in this case, rather than it being delta F over delta X, it would be delta B over delta M. I'm going to put this in my calculator. If I wanted to put the entire thing in my calculator, make sure you put parentheses around your entire numerator and entire denominator. I end up getting the average rate of change is 28.398. Now, for 2, we want to find 19 to 69. So 19 to 69. You're going to do the same thing. Difference in output over difference in inputs. If you're putting the whole thing in your calculator, make sure your entire numerator and entire denominator are encapsulated in parentheses. You get 32.76. We're going to do the exact same thing for this one. Month 36 to 72. So 3,135.8 minus 1,770.8 over 72 minus 36. If I'm putting the entire thing in my calculator, make sure you put parentheses. You get 37 0.916 bar. And then lastly, for 4, month 60 to 73, difference in outputs over difference in inputs. So 3,186 minus 2,591.9 divided by 73 minus 60. You get 45.7. So which had the greatest average rate of change? Interval 4. Okay, now we have another average rate of change question. And it's asking which average rate of change is the fastest. So you could use that formula that we just did, or you could kind of connect those. You could show the average with linear functions, right? So from 1 to 2, make that a little bit thinner. From 1 to 3.5, already you can see that the blue is increasing at a faster rate. One to 5, there's actually an average rate of change of 0. There's no change, right? And then lastly, 0 to 3.5, and you could see just by the rate that they're increasing at, the slowest is the purple line, the next slowest would be the green, the next slowest would be the red, and then the quickest was the blue. And the blue is the one that we did first, so that is 1 to 2. Again, you could pretty much estimate where these points are and do it, just as we did the last problem, but that would take a lot of time. And this was just a multiple choice question. Okay, we have another average rate of change question. The distance needed to stop a car after applying the brakes varies directly with the square of the car's speed. We're given a table of values. Determine the average rate of change from 50 miles per hour to 70 miles per hour. So you're going to do difference in outputs over difference in inputs. If you want to, personalize this to the question, this is delta D over delta S, right? Change in distance over change in speed. Put that in your calculator, and you'll get your average rate of change. This equals 7.5. So, the average rate of change in braking distance, feet per mile per hour, is 7.5. Explain what this rate of change means as it relates to braking distance. So, the best tip I could give you is restate the question. Say, between 50 miles per hour and 70 miles per hour, each additional mile per hour requires an additional, I'll say, requires on average an additional 7.5 feet of braking distance. Okay. Now we're moving on to the next standard in this unit, which is inverses. I always recommend rewriting F as Y, right? If we want to be precise, but if this, like I said, if this confuses you, don't do this step. But if you want to be precise, really, you should define F as Y. So now we could substitute f of x for y. Still the original function, right? Now, when you want to find the inverse, you switch the x and the y. Now, without doing anything further, we found the inverse. The minute you switch the x and the y, that's your inverse equation. But we're used to having equations in terms of y, or solve for y. So, I would distribute out the honestly, you don't even have to distribute the negative 6 if you don't want. You could divide by negative 6 on both sides. You could distribute first, but it's just an extra step. Add 2 on both sides, and you have y equals negative 1/6 x plus 2. Remember, we said in the beginning that f of x was y. This, since we switched the x and the y, that's no longer y, right? That's the inverse of y. So that's the inverse of f of x. Is that one of our answers? It looks like positive 2 and negative 1/6 x. So the answer would be 2. Okay. We have another inverse question. So we have y equals 1/2 x plus 8. Switch the x and the y. Subtract 8 on both sides. You could multiply by 2 on both sides because that's the opposite of dividing by 2, which is just what 1/2 is. We have y equals 2 times x minus 8. Distribute out that 2. And it's saying that g of x is your inverse. So g of x equals 2x minus 16. Okay. Again, the only thing you're doing, switch the x and the y, and then solve for y. We're going to do the same thing here. Switch the x and the y, solve for y. Right? When you're dividing an expression by, let's say, 4 in this case, you would be doing x divided by 4 and negative 5 divided by 4. That's how we have these two terms. Okay, now we have systems of equations, and that looks like the last standard that the Regent could test you on for Unit 1. So with 3x3 systems, the easiest thing you could do is elimination. And with elimination, you have two rules. You can combine equations by addition or subtraction, or you could multiply by a number. So since equations are proportional, if you multiply by a number on both sides, still the same equation. So we want to eliminate a variable. And I'm looking and I see something that would be really easy to eliminate is if I combined, I'm going to label my equations. Equation 1, equation 2, equation 3. If I combined equation 1 and 2, because x plus negative x would just cancel out. It equals 0. So let's write that out. Equation 1 plus equation 2. And let's rewrite the equation. So x plus negative x cancels out. 2y plus negative 3y is negative y. Negative z plus 2z would be z. 1 plus 0 equals 1. And let's call that equation star, because that will be one of our two variable equations. Now, we used equation 1 and 2. We must use equation 3. And we also must get rid of x, because we eliminated x in equation star. So, it doesn't look like I have negative 2x anywhere, right? But again, remember that rule that I said. You could multiply an equation by a number. So I could either multiply equation 1 by negative 2 and get negative 2x to cancel out 2x, or I could just multiply equation 2 by positive 2, because there's a negative on the x already. So that's what I'm going to do. I'm going to do 2 times equation 2 plus equation 3. And if you want to do the math for 2 times equation 2 somewhere else, that might be a little bit neater. Make sure you're doing it on both sides of the equal sign. So you would have negative 2x minus 6y plus 4z equals 0. 2 times 0 is 0. So we did do the distribution, you just can't really see it. So let's write that. Negative 2x, 2 times equation 2 is negative 2x minus 6y plus 4z equals 0. And then equation 3, we already have, it's 2x minus 4y. It's given in the question. Add those up. Cancels out. Negative 10y plus 5z equals 10. And we'll call that equation triangle. So now we have a 2 by 2 system. And if you want to see the 2 by 2 system, we could rewrite those two equations. Okay? And it looks like we're going to have to multiply by a scalar factor or a number. Let's multiply by negative 5 so that we get negative 5z, and that would cancel out. So we're going to multiply equation star by negative 5, and then we're going to add that with equation triangle. So if you want to do that math somewhere else, let's say negative 5 times equation star. Make sure you're distributing out to both sides of the equation, including the other side of the equal sign. Whatever you do to one side, you must do to the other. And then we just have to write that. So 5y minus 5z equals negative 5. Now I'm going to write equation triangle. Five y minus 10y is negative 5y. Negative 5z plus 5z cancels out. Negative 5 plus 10 will just be 5. And you canceled out x and z now, so you could just solve for y. Five divided by negative 5 is negative 1. Now we solve for y. From there, you don't have to do elimination anymore. You could just start plugging in. So we're going to plug in y into one of our two variable equations. Let's use star. I'm going to plug in negative 1 for y. I get 0 for z. And now I'm going to plug in into one of the three variable equations. Let's use equation 1. We don't know what x is yet, that's what we're solving for. Plus 2, y is negative 1, z is 0. 2 times negative 1 is negative 2, minus 0 is just negative 2. Add 2 to both sides, you get x equals 3. So the point of intersection for those three variables, for those three equations, are x, y, z equals 3, negative 1, 0. And your answer would be 2. If you want to try to visualize what this would look like, these are linear equations, meaning that these are lines. And it's three variables. Typically, you deal with two variables, and that would be 2 dimensions. Three variables would be shooting off the page, right? It's the third dimension. The best way you could probably visualize it is picture it as lasers, right? If you point out one laser, you're going to have a long straight line in 3 space. Then you have another laser. You're going to have another long straight line in 3 space. And then you have another laser, because it's 3 equations. Those lines could completely miss each other, right? As long as they're parallel, right? Because they go on forever. And then there would be no solutions. Those lines could be parallel and collinear, so on top of each other. So there could be infinitely many points. Or those lines could only have one point of intersection because they cross at one point. You can't have more than that. So it's either 1, infinitely many solutions, or no solutions. Okay. Now for this question, it's another systems of equations question. Label your equations. We have, honestly, it looks like x would probably be easy to cancel out again, just because you have 1x here, so you can multiply by negative 2 and get rid of that 2x, or you can multiply by positive 4 and get rid of negative 4x. Same thing with y. Y wouldn't be so difficult. Oh, and z. What did we get rid of in the last one? The last one we got rid of x first, so let's get rid of z first, just to show that it doesn't have to maintain any really order. So, if we want to get rid of z, I'm going to multiply by 4 to get rid of negative 4z. So we're going to do 4 times equation 3 plus equation 1. So if you want to do that math in another spot, 4 times equation 3 would be 4 times negative 4x plus y plus z equals 16. Distribute that out to both sides of the equation. So you have negative 16x. You have positive 4y, positive 4z, and then 4 times 16, 64. So let's rewrite that. Negative 16x plus 4y plus 4z equals 64. And then equation 1 is 2x plus 3y minus 4z equals negative 1. Let's combine those two equations. Negative 16 plus 2x, negative 14x, 4y plus 3y, 7y, 4z minus 4z cancels out, 64 minus 1 is 63. That is equation, let's say, star. You could label them whatever you want. So now, let's do, so we used equation 3 and we used equation 1, so we must use equation 2 now. Also, we must cancel out z since we already eliminated z. So, if we have to get rid of z and we have to use equation 2, we're going to have to multiply equation 3 by negative 5. So negative 5 times equation 3 plus equation 2. If you want to do that math somewhere, let's say negative 5 times equation 3 negative 5 times negative 4x, positive 20x, negative 5 times y, negative 5y, negative 5 times z, negative 5z, negative 5 times 16, negative 80. Let's rewrite that down here. The key to these questions is being neat. I've had so many students that were completely capable of doing this and knew exactly what to do, but because they were sloppy and it was unorganized, they lost track of their work. Make sure you try to, write your work in lines. If you go step by step and then you finish that part of the page, go to the right side of the page. If you want to draw a little line, draw a little line, right? I really recommend being neat. If you need scrap paper, use scrap paper. Okay. X minus 2y plus 5z. I'm just rewriting equation 2. Let's combine those. Negative 5z plus 5z cancels out. We'll call that equation triangle. Now we have our 2 by 2 system. If you want to show the 2 by 2 system, you could rewrite them. Ooh, look, we don't even have to multiply by a scalar factor. It just cancels out. Before I say it, do you see what's going to cancel out? The 7y, because 7y minus 7y. So all you have to do is equation star plus equation triangle. You know, yeah, it's fine. I'll rewrite it. I'm rewriting it for you guys. Trying to, enforce good habits. 21x minus 14x would be 7x. 7y minus 7y cancels out. 63 minus 77 is negative 14. Divide by 7, and you get x equals negative 14 divided by 7 is negative 2. Now we're going to plug into one of our two variable equations. So let's plug into equation star. Negative 14 times x is negative 2 plus 7y equals 63. That would be positive 28 plus 7y equals 63. Divide by 7, you get y equals 5. Lastly, we're going to plug into our 3 by 3 system. And we're solving for z. Looks like where z is by itself, that's like the easiest one to use. So negative 4 times x, which is negative 2, plus y, which is 5, plus z equals 16. So negative 4 times negative 2 plus 5 is 13. Subtract 13 on both sides. 16 minus 13 is 3. So that point of intersection x, y, z equals negative 2, 5, 3. Okay. A way you could check your work, you could just try plugging into more than one equation and see that those are, in fact, points of intersection. You have to make each equation work. Okay. So I think that's good enough for the Unit 1 review.